Hello students, let us continue with chapter 12 electricity. In the previous video, you have studied the two combinations of resistors, series combination and parallel combination. And we have also derived an expression for effective resistance for the series combination of three resistors and also for the equivalent resistance of the parallel combination of resistors. Now you can just let us recall. Here we have three resistors connected in series and the effective resistance or equivalent resistance RS is equal to, it is a sum of the three resistors which are connected in series. So RS is R1 plus R2 plus R3. As we can see here, I have not drawn the complete circuit. Same current will flow through each of the resistors in series combination. And ammeter which is connected in series in the circuit to measure the current, it is going to measure that current I, which is common for each of them. And if I connect a voltmeter across this R1, across means in parallel with R1, it will give me potential difference across R1, that we had denoted it by V1. If I connect it across R2, it will give V2. If I connect it across R3, it will give V3, potential difference across R3. And if the voltmeter is connected across this entire series combination with its one terminal, positive terminal towards this side and negative terminal towards the other end of R3, then it is going to give the potential difference across this series combination that we had denoted by capital V. And we know in series combination, one thing, current remains the same. Second thing, potential difference gets divided, and in this case then V will be equal to V1 plus V2 plus V3. So total potential difference across this combination will be equal to sum of the potential differences across each resistor. Similarly, when the resistors are connected in parallel as shown there, then we know that ammeter has to be connected in series in the circuit to measure the total current in the circuit. So if the total current is I here, okay, and it gets divided as it reached the first common point of this parallel combination. And we had considered that let I1, I2, I3 be the currents through the resistors R1, R2 and R3 respectively. So here I have shown voltmeter which is connected in parallel with the parallel combination. So voltmeter is going to measure the potential difference which is same for each of them, and that was represented by capital V. Now you also know, if you are asked to measure the current through each resistor, where you are supposed to connect the ammeter in series with R1 to measure I1, in series with R2 to measure I2, in series with R3 to measure I3. And in the case of parallel combination, the effective resistance Rp is given by this expression. 1 over Rp is 1 over R1 plus 1 over R2 plus 1 over R3. So from here, we can remember that when the resistors are connected in parallel, potential difference across each of them remains the same, and current gets divided through each of them in such manner that the total current I will be equal to I1 plus I2 plus I3, sum of the currents through each resistor. So here remember both the things for series as well as parallel combination. Remember about potential difference and current conditions. Now let us just take three resistors having resistances 1 ohm, 2 ohm, 3 ohm, and let us just check what will be their series and parallel equivalent resistances. So if they are connected in series, then the effective or equivalent resistance RS will be 1 plus 2 plus 3 as per this formula is equal to 6 ohm. So we can see that the equivalent resistance for the series combination is the sum of the three, so it is the maximum of these four values. It means series combination is used to increase the resistance in a circuit and hence to decrease the current, as current is inversely proportional to resistance. Now let us consider that the same three resistors are connected in parallel. Then the equivalent resistance Rp will be given by 1 over Rp, just put the value for R1, R2, R3 as 1, 2, 3 ohms respectively. So after doing the calculations, we can get 1 over Rp is 11 by 6 and Rp is 6 by 11, that is 0.545 ohm. Sometimes students, in case of numericals, students write 1 over Rp is 11 by 6 and they forget to take the reciprocal. They just write the answer as 11 by 6 ohm. It is wrong. Now we can here analyze that Rp is 0.545 and when we look at the values of the three resistors, minimum is 1 ohm and it is smaller than the least value of the resistance in the combination. So we can consider parallel combination is used to reduce the to reduce the resistance in the circuit and hence to increase the current, because current and resistance, they are inversely proportional to each other. Okay, I hope this is clear to you. Now what happens when resistors are connected in series or when they are connected in parallel? What happens to the current? It's clear to you. Now, as I have told you earlier that every component or every device offers some resistance to electric current or to the flow of electric charges through it. Now in the circuit, ammeter and voltmeter, they are the measuring instruments which are used to measure current and potential difference respectively. So even if we don't connect them, it should not affect the circuit. They are just used to measure the current. They are measuring the measuring instruments. So ammeter is used to measure the current. Voltmeter is used to measure the potential difference. If you don't connect this ammeter in the circuit, the only thing is ammeter, it should not be left open. It should be a straight line. It means ammeter is not connected. Take the ammeter out and there should not be open gap anywhere in the circuit. Circuit should not be broken. Then the circuit should work as normally as it was working before without ammeter. The only thing is you cannot measure the current using, ammeter is not connected. You are not measuring the current. Similarly, in that case also, when you don't connect the ammeter, it should not affect the circuit. The working should be same as that of before, only the current is not measured by ammeter in the circuit. Now, same thing for voltmeter. When voltmeter is connected, it is measuring the potential difference across this parallel combination, or when voltmeter is connected here across R1, it is measuring potential difference across R1. But if we remove the voltmeter, it means we are not measuring the potential difference, but it should not affect the working of the circuit. Working of the circuit means it should not affect the effective resistance. It should not affect the total current in the main circuit or in the resistors. Then, if I ask you, they are measuring instruments, but they are some devices, so they must be having certain resistance values, because every object or every conductor, every device offers some resistance. Even insulators, they offer resistance. Their resistance is very high. Okay, so let us see. If I ask you, or if you are asked a question, what is the resistance of an ammeter or what is the resistance of a voltmeter, what answers you are going to give, or you should know the values for that, answers to these questions. Now, ammeter is always connected in series in the circuit when it is used to measure the current. But I told you it should not affect the total current or total resistance of this combination. So it means that if I use here Rs as an effective resistance, as ammeter is connected in series, and if I represent R ammeter as a resistance of ammeter, then Rs plus R ammeter should be equal to Rs. As I told you that ammeter's resistance should not change the resistance of the combination or of the circuit. So this is possible when R ammeter is equal to Rs minus Rs 0 ohms. So this is the ideal value of the resistance of an ammeter, or in other words, an ammeter should ideally possess 0 ohm resistance. But practically it's not 0 ohm, it is very low. It means when we use ammeters in the lab, they have very low resistance so that the total resistance of the circuit remains the same. They are not affecting the resistance of this. They are just measuring instruments. Ideal ammeter resistance is 0 ohm. Practical ammeter resistance is very low. So remember answer to these questions. What is the resistance of an ideal ammeter? What is the resistance of a practical ammeter? Now let us see in the similar manner what is the value of ideal voltmeter or practical voltmeter. Now for this, if voltmeter is connected in parallel with this combination or with any of the resistors in the circuit to measure the required potential difference, it should not affect the effective resistance or equivalent resistance of the combination. So as voltmeter is connected in parallel with the parallel combination where the effective resistance is represented by Rp, and using this expression I can write the net resistance of the voltmeter and this parallel combination will be given by 1 upon Rp plus 1 upon R voltmeter, where R voltmeter is the resistance of voltmeter. And as I have told you, this effective resistance of the two of the parallel combination and the voltmeter should be equal to the effective resistance of the parallel combination only, that is Rp. So this should be equal to 1 upon Rp because it should not affect the total resistance or total current in the circuit. This is possible when 1 over R voltmeter is equal to 1 over Rp minus 1 over Rp, that will be 0 ohms. And 1 over anything is 0 ohm, you know, when when the denominator is infinity. So R voltmeter is equal to infinity ohm or infinite ohms. So we can write resistance of an ideal voltmeter is infinite, very large, infinite. But practically voltmeters and resistance is not infinite, it's very high. So just remember, resistance of ideal voltmeter, infinite ohms you can say, and resistance of practical voltmeter, very high. And thus these are just measuring instruments which do not affect the net current in the circuit or net resistance in the circuit. But practically we can consider, since they are not ideal cases are a bit different than the practical, so slightly they may affect, but that we can ignore. So I hope this topic is clear to you. Now students, if you are asked the question, give the disadvantages of series circuit or advantages of parallel circuit or advantages of parallel circuit over series circuit, in any of the questions you have to write both the points. For parallel you have to compare the same point for parallel as well as the series circuit. Here parallel circuit means devices are connected in parallel and series circuit means devices are connected in series. So one thing you already know that in series combination current through each device will remain same. On the other hand, in parallel combination or in parallel circuit where devices are connected in parallel, the resistance decreases, current increases, and also current gets divided across each device which is connected in parallel. So keep this thing in mind and let us see our first point. In a series circuit, the current is constant throughout the electric circuit. So if suppose we talk about electric bulb, electric geyser or electric fan, electric tube light or television, they cannot be connected in series because each of this device require different amount of current to operate properly. Okay, so we cannot connect them in series because in series current through each of the device remains same. So we can write here, it is impracticable to connect an electric bulb and an electric heater in series because they need currents of widely different values to operate properly. So we have mentioned the disadvantage of series circuit. Let us see what is the advantage of parallel circuit considering the same point. On the other hand, a parallel circuit divides the current through the devices, electrical gadgets here. It divides the current. So the total resistance in a parallel circuit, we know it is decreased. This is useful particularly when each gadget has different resistors and requires different current to operate properly. So this is just the reverse of this. Here the current remains the same. So components which require different currents to operate properly cannot be connected in series. In parallel circuit, resistance gets decreased, current gets divided. So components which require different currents to operate properly can be connected in parallel. Now let us see another disadvantages of series circuit or advantage of parallel circuit. Now we know that in series circuit all are connected, all the devices are connected one after the other. So if any component fails in the series circuit, then the circuit is broken, it is open and the components will stop working. Okay, and for parallel combination or in parallel circuits, their devices are connected in parallel, means between the same 2 points. So if any component is faulty or fails to work properly or it stops working, still the other circuit is completed, the circuit is not broken and the other components will work properly. So this is the disadvantage of series over parallel circuit considering this point. Let me read here. Another major disadvantage of a series circuit is that when one component fails, the circuit is broken and none of the components works. In parallel circuits, when one component fails, the circuit is not broken and the other components work properly. You must have seen the fairy lights that are used for decoration during festivals like Diwali, Christmas or New Year, or for marriage occasions. During marriage, the fairy lights which are used, sometimes the lights are not working properly. We know the light consists of many bulbs connected in series. There are different layers which are connected in parallel, but each layer has large number of small bulbs, very small bulbs of very less power connected in series. So if the layer is not working properly of fairy light, then when we call the electrician, he has to do work, he has to spend lot of time in finding out one out of many bulbs which bulb is faulty. And that is time consuming, he finds it out and then removes it from the circuit. Then that layer of fairy lights start working properly. So I hope you have understood the advantages of parallel circuit and disadvantages of series circuit, or advantages of parallel circuit over series circuit. So just remember, revise the topics. Today we have done what is the resistance of ideal voltmeter and practical voltmeter, what is the resistance of ideal ammeter and practical ammeter, what are the advantages of parallel circuit over series circuit. Now if you have understood this, just think over this question. If you have an electric circuit, if you have connected an electric circuit in your lab and you have used ammeter which is connected in series to measure the current, you have used voltmeter which is connected across any of the resistor, let it be series combination or parallel combination. We know when we have series combination, voltmeter will be connected across each or a set of resistors. When it is parallel combination, voltmeter will be connected across each of them together. Remember, if your ammeter stops working, if it is faulty, what will happen to the circuit? The circuit will not work, because if your ammeter is faulty, you may feel other devices are faulty, but maybe just because of faulty ammeter, the circuit is not working properly. But if your voltmeter is faulty, ammeter is fine, then what will happen? If your ammeter is fine, voltmeter is faulty, then the circuit will be working, ammeter will be showing the reading, but voltmeter will not show any reading because it is connected in parallel, it is faulty. So yes, it is not showing any reading, but it is not affecting the working of the circuit. Circuit will work properly, current will flow through each component. So I hope the topics that we have covered today are clear to you. We'll continue with this chapter in the next video. Thank you, students.